You wake up. You reach for a glowing rectangle of glass and metal. You tap the screen, and instantly, billions of microscopic switches flip in perfect harmony. You don't think about what you are actually holding. You don't think about the violence it took to create the silicon beneath your fingertips. For roughly 4 billion years, the foundation of every processor, every microcontroller, every piece of bare metal logic was just dirt, crushed shells, ocean debris, the mundane, chaotic sand washing up on the shore. But you cannot build a microscopic city of logic gates out of chaos. It needs to be pure, not just clean. We are talking about a level of purity so extreme, it has its own name. 9 nines.
99.99999999999% pure.
So, how do we get there? We blast the sand with carbon and chlorine gas at temperatures that would melt a volcano. We strip away the oxygen, the impurities, the entire history of the ocean. What we are left with are chunky, shiny gray rocks, polysilicon, beautiful, but flawed. Because inside these rocks, the atoms are chaotic, jumbled, total atomic anarchy, and anarchy cannot run a single line of code. We need order, perfect, mathematical order. So, we melt the rocks. We throw them into a massive crucible and crank the heat to over 2,500 degrees Fahrenheit. The solid rock becomes a glowing, blinding, liquid soup. And here is where the story shifts from chemistry to something profound. We take one single, perfectly structured crystal of silicon, a seed, and lower it into this molten liquid on a string. As we slowly pull the seed upward, the liquid cools, and as it cools, it perfectly copies the seed's atomic structure. Row by row, atom by atom. What emerges from this blinding heat is a 200-pound crystal cylinder, an ingot, the literal foundation of the entire VLSI industry. Let that sink in. It is the most perfectly structured object ever created by human beings. There are 0 natural objects on Earth this pure. A group of humans in a factory created something more perfect than anything nature has produced in 4 billion years, just so we could trap lightning inside a rock and teach it how to think. But this absolute unit is still just a heavy, useless cylinder. You cannot build complex circuitry on a cylinder. You need flat surfaces, impossibly thin, perfect silicon wafers. So, what happens next? We grab a diamond saw, and we start slicing. Subscribe so you don't miss the slicing. Like the video so you can see the new like animation on YouTube. See you in the clean room.